Hi everybody. Welcome back again. We'll move on with topic 8 today, and this time we'll look at population statistics. This should be a fairly straightforward one. Basically, the syllabus just says we need to know 5 terms, which you can see above my head. So let's start as usual by looking at the syllabus. I won't just read out this. This is copy and pasted from the syllabus. I'll just refer to these things above my head. As usual, the IB likes jargon. They like using acronyms, so you're going to have to remember these, I'm afraid. The 5 things you need to understand in terms of knowledge are the crude birth rate, the crude death rate, the total fertility rate, the doubling time, which obviously is the time taken for a certain population to double in size, and the natural increase rate. So basically in this video I'll just talk about those 5 things and the definitions of them. In terms of applications, it just says you need to be able to calculate them and you need to explain their meaning. So therefore, in order to calculate them, I'm afraid you're going to have to learn the formulas. But the good news is if you learn the formulas, you automatically you can define them in terms of words. So the formula will give you the definition. Okay, a couple of slides just before I move on to those definitions. If I just flip back to the previous video we did about human population growth, you remember that there was a United Nations model, and that model said that by the year, well in this case 2100, the human population could be the low estimate 5.5 billion, the highest estimate 14 billion people on the earth, and the kind of consensus value that most people think will happen is that by 2050, when you're my age, the human population will have started to level out at about 9 billion people. So the question is, how did the United Nations come to use that model, or what do they use for that model? And the answer is they use those statistics that we're going to talk about today. Just a couple more things again before I get to those definitions. It should be fairly obvious, but you should realise that population change and these statistics, by definition, are not equal throughout the world. They're very different in very different countries and different societies. Human population is likely to increase over that time in North America and Latin America in particular. In other areas, population might fall. China, or the western part of the former Soviet Union. And population is likely to increase but at a lower rate in parts of Africa and in the Indian subcontinent. Now we'll come back to those and the reasons why in future talks we'll do together. But obviously you've already realised that these things depend on culture, religion, historical aspects, that kind of thing. So just bear that in mind. And again, just before I move on to those statistical definitions, remember please that populations are likely to change or likely to increase most in megacities. Megacities are defined as cities with more than 10 million people. So that obviously includes Mexico City, where we are now. The biggest changes are likely to happen again in China and around the Indian subcontinent. Again, in parts of Latin America as well. And a couple of cities in the United States. Mexico City, for example, is likely to increase to about 25 million people. Now you know that figure is very dodgy because currently I've heard estimates that the current population in Mexico City could be touching around 30 million. The problem there is where you get your data from. You get it from censuses. Censuses are not particularly reliable in Mexico. You get it from employment data. Well, employment data is not useful because so many people here work on the black economy and the black market. And again, another problem with megacities like Mexico City is that there's huge amounts of immigration and there's emigration occurring as well. The population in Mexico City can be at times quite transitory. People moving in and people moving out. at the moment, particularly in terms of immigration into the city. I don't want to dwell on that because we'll come back to it, but it's just worth mentioning as well that population specifically is going to change in these mega cities. So you might want to pause the video there and just take a look at that graphic and look at those projected changes in those specific cities. Okay, so moving on, let's talk about the definitions. I'm not going to do them in the same order as there is above my head. I'm going to start with total fertility rate because that's something that I covered in the previous video when we talked about population change. It was the only one I spoke about. So you already know that total fertility rate, or TFR, is defined as the average number of births per woman per lifetime. Obviously, I'm not suggesting that a woman has more than one lifetime, but it's just to make the point that you could talk about fertility rate of specific age groups, specifically of women. In this case, we're talking about whole lifetime fertility rate. So total fertility rate, the average number of births per woman per lifetime. Please remember that. Here we've got two together because they're similar. The crude birth rate and the crude death rate. The crude birth rate is the total number of births per 1,000 population. And you can express it mathematically as well. The crude death rate is the total number of deaths per 1,000 people in a society. So again, obviously you need to define the population you're talking about. Are you talking about a megacity? Are you talking about a country? Are you talking about the crude birth rate and crude death rate of the planet overall? Okay, that should be fairly straightforward. That leads us to the, well, I've put two here. The one we're interested in is the natural increase rate. Before I do that, I'll just define the natural increase. The natural increase is just the crude birth rate minus the crude death rate. So the number of extra lives added per 1,000 population. However, natural increase rate is always defined as a percentage. This might be a bit confusing. So the natural increase rate is natural increase divided by 10. The reason why the number 10 is included there is because it's defined as a percentage. You need to convert from every 1,000 people into every 100 people. So therefore you're dividing 1,000 by 10 to achieve that. So again, you might want to pause it there, make sure you've written that down, and make sure please you understand the difference between natural increase and natural increase rate. Just remember it's in terms of percentage here. Which leaves us to the final one. The final one is the doubling time. The doubling time is the number 70 divided by the natural increase rate or percentage growth. It's called the rule of 70. 70 comes from 70 being the average assumed life expectancy. So it's the number of years that it would take for the population of a defined place to double in size. 70 divided by natural increase rate. Okay, that's it. It is just a matter of going through the video, maybe pausing and make sure you write down those definitions. And when I post this, I'll post it with some questions so you can test your understanding. Quite a quick one today. Hope everybody's okay. Not too many stresses at the moment. My biggest stress is what's happening to my hair at the moment. It's starting to go very bouffant. It's starting to make me worried about what I'm going to look like on these videos in 2 weeks' time or 3 weeks' time. But we'll cross that bridge when we come to it. That really is the definition of first world problems. I hope your family's okay and you're okay. Take care of yourselves. Try to keep working hard, but not too hard. Okay, goodbye everybody.